Next property is electrical property. In electrical property, we'll see the electrical properties are characterized by mean free path of electron. The mean free path changes at the nano scale due to collision and tunneling within the conductor. So inside the conductor, we observe sometimes there is a collision between the charge as well as tunneling within that conductor. IV characteristic of bulk conductor, that is IV characteristic means current and voltage. When voltage V is applied to across the conductor, current I flowing through it is governed by Ohm's law and has linear variation. That Ohm's law you already know. So we can show this in diagram how Ohm's law observed in bulk material and nanomaterials. See, in bulk material we know I is diagram proportional to V. So that is in IV it is straight line, where if you observe in nano, that time it is not a linear line, it is staircase. See, for some voltage that current is not increases, but after some time as within some fraction the current increases, then again though voltage increases, current will be a constant, then directly increases. Though with a constant voltage, current get increases. So we are saying it is Coulomb staircase. The IV characteristics of nanoscales, that is at nanoscale, if the dimension of conductor are in nanoscale, there appears a region around the zero voltage for which there is no current. A single electron is transmitted by tunneling when voltage is plus minus E by 2C. Therefore, when voltage is less than these electron cannot be transmitted. That time current will be zero. This gives the region of zero current at low bias voltage is known as Coulomb's blocked region. The electrons are transferred when voltage is plus minus E by 2C. The repeated tunneling of single electron produces Coulomb's staircase. Electroresistivity. The materials of nano-size grain have a large number of grain boundaries than corresponding polycrystalline materials. Electrical resistivity of material having nano-size grain is larger than polycrystalline materials due to scattering of electron at grain boundaries. This is about electrical property. So last property is mechanical property in nanoparticle that we'll see. Mechanical properties of material depend upon the composition of material, bonds between atoms, and presence of impurity. When the size of material is reduced, nano in nanoscale, the material tends to single crystal. So, in short, in mechanical property, what we are saying, what are the composition in that material, how much bonds are strong bonds or weaker bonds, and how much impurity is there. Depend on that, the mechanical properties are varies. But when the material is reduced in nanoscale, that time instead of all such bonds and that, it observes a single crystal. That crystal we can see these nanoparticles which having dimension in nanometers. This nanometers dimensions. Then this is nanorods having length in nanoscale, and this is nanotubes. These nanotubes mostly is used in also used in nano car. Okay, so carbon nanotubes are used. Next, the measurement of electricity, hardness, ductility show different behavior as compared to bulk material. For example, in the case of metallic nanocrystalline material, elastic that's elastic modulus reduce dramatically. We know the elastic modulus that is changes dramatically. For that purpose, we can see this table where the material Mg is given in nanocrystalline form. The grain size is 12 nanometer, and that time it has Young's modulus is 3900 Newton per mm square, while when it is polycrystalline, that time grain size is less than 1 mm, and that time it having Young's modulus 4100 nanometer per mm. So it is clearly observed that as the material convert into nanoform, the Young's modulus is increases because see it is very close. 12 nanometer is very small. Still, it is having this much a Young's modulus as compared to when it is in polycrystalline form. The plastic deformation in nanocrystalline material is strongly differ from that of polycrystalline bulk material. That is, if stress is removed, the recovery of original shape or size is recovered more efficiently in nanomaterial. We can see this about hardness. For bulk materials, as size increases, its hardness increases. But in nanomaterial, with increase in size, the hardness goes on decreasing. So this hardness of material is also related to grain size. In the nanometer energy range, the hardness increases with decrease of particle